Iterative Heapify. In the previous lecture, we learned about Heapify operation. We understood what is Heapify, how to apply Heapify, what are the steps to be followed in order to apply Heapify operation. And we also understood what are the conditions and under what circumstances you can use Heapify. And then we went through the recursive algorithm and we understood that for the recursive algorithm of Heapify, time complexity is order of log n and the space complexity is also order of log n. What we are going to do in this lecture, we are going to go through the iterative approach for Heapify algorithm. And why are we specifically going to the iterative algorithm? Because with iterative algorithm, you can achieve a space complexity of order of 1. That is, you can complete whatever you did it with order of log n space complexity in recursive algorithm in constant space if you are using iterative algorithm. And why is this? Because iterative algorithm doesn't make use of the recursion stack. So the recursive stack is what takes up order of log n space in case of recursive algorithm. So here we are specifically looking into the iterative algorithm. What things do you need to know in order to write iterative algorithm? You need to know the process, which we already explained in last lecture. What are we going to do? We are going to start from the root and we are going to propagate till the point we complete Heapify operation. So 3 things you want to know. One is the root node, we call it I. Then the left child is 2i plus 1 and the right child is at 2i plus 2. So this is according to the array representation of heap where you can directly access the indices of left and right child of any node by going to 2i plus 1th index and 2i plus 2th index. So let us start with the iterative algorithm. So here I am directly going to the algorithm because we already explained everything in last lecture. So I am not explaining again. We'll directly go to the algorithm and keep in mind we are writing max Heapify algorithm. So if you want to do min Heapify, wherever we do largest, you take smallest. Wherever we are taking maximum, you take minimum. So then you will get min Heapify algorithm. The algorithm would remain the same. Wherever we are doing any comparisons, instead of largest, you should take smallest. That is the only thing you have to do. So we are going to write the max Heapify iterative algorithm. So we'll call it max Heapify on array. I is the node on which you want to apply Heapify and n is the size of the array. So this is array representation of heap. What are the variables you want? One is you want largest. This will keep track of whichever is the largest element. Then you should have a variable left to keep track of left child. And you should have a variable right to keep track of right child. So let us start with the variables. Largest, we'll assume largest is equal to I. And then in case of recursive algorithm, we had directly mentioned left and right variables at the start of the algorithm itself. Here, because it is iterative, you are not going to call this again. When you're calling this again, the advantage is that left and right used to get updated whenever you call it again and again. But here, because it is iterative, you will call the function only once and the updation will happen inside the loop, which means you have to define left and right variables inside the loop. So we'll start the loop. You'll have a while loop, while 1. Why am I having while 1? Because this loop should continue till the base condition on which you will exit. So that exit condition will put inside this while loop. Okay. So while 1, what will you do? You need the variables. What are the variables? Left. What is left? 2i plus 1. And what is right? Right is 2i plus 2. So these are the indices of left child and right child of the node. So now you know what is the node. It is I. What is the left child? It is 2i plus 1. And what is the right child? It is 2i plus 2. The next thing is you have to compare these 3 and understand which is the largest. So first we'll compare with the left child. The same thing that we did in recursive algorithm. If left less than n. Why are we doing left less than n? So that to confirm that the left child exists, because this left may go out of bounds. So in order to confirm left child exists, we do left less than n and then and what is the second condition? The left should be larger. So AR of array of left, that is whatever is the value inside left, if that is greater than AR of larger. So already you are assuming that largest is whatever is at the root. So if whatever is at the left child is greater than whatever is at AR of array of largest, that is presently it will be root. If left child is larger, then what do you want to do? You want to update your largest variable. The variable called largest, you will update it to left, because you know left is largest right now. Next thing, you will do the same thing for the right child. If right is less than n, and what is the second condition? Array of right, whatever is pointed by the right node, if that is greater than AR of largest, in that case what will you do? You will update largest as right, because you know right is the largest. So when you complete this much, what do you have? Among the node, its left child and the right child, whichever be the largest value, you will have that index in your variable called largest. That is what you have at this point. What is the next thing to do? You want to check whether this largest is the root node or if it is the children. If it is root node, you are done. You don't have to do anything else. Your Heapify is completed. If it is the children, you have to continue Heapify on those children. So what will you do now? You will have a condition again. If largest equal to I. If largest is equal to I, that means whatever is at your new root, if that is the largest, what will you do? You will just skip from here. You can break, because you are done. You are done with the algorithm. You can break from here. Otherwise, if it is not, else, what will you do in this case? You have to swap whichever child is the larger with the root. So how will you do? Else you want to swap AR of I with array of largest. So you swapped the root node with whichever child is having larger value. After this, in case of recursive algorithm, we simply call the algorithm again with modified parameters. Here, because it is a iterative algorithm, what are you going to do? Instead of, you can't call the algorithm the same function again, because that will be recursive. Instead of that, here you will simply update. You will update I is equal to largest. When you update this, what happens? New value of I is the updated node. So if your left child was largest, you exchange these values, and then you are saying previously my I was this, now my I is that of the largest value. So you are again calling the same thing on I. So I is largest, and then you will again continue the while loop. So this is the iterative algorithm for Heapify operation. What is the time complexity? Time complexity will remain the same order of log n, because maximum number of steps is the height of the tree. Whatever is the maximum height of the tree, that is heap here, whatever is the maximum height of the heap, that will be your maximum number of steps, because you are propagating downwards. And heap is a complete binary tree. Maximum height possible for a complete binary tree is order of log n. Because of that, time complexity is order of log n. And space complexity, here you are not using any recursion stack. You are not using any extra space other than the variables that you are using. So variables are taking only constant space. So your total space complexity is constant, order of 1. So your time complexity is order of log n. Space complexity is order of 1 if it is iterative approach.